So guys, hello from Intellipaat. Hope you've been having a wonderful day. The topic of today's session is Java tips and tricks. But before we begin, be sure to hit that subscribe button and click on that bell icon so you don't miss out on any updates from us. So let us begin with the video without any further ado. So today's agenda is why programming practices are important. We will discuss that from an industry standpoint and from a personal project standpoint as well. We'll discuss what good programming practices are and why they are important. Then we'll discuss the types of programming practices that we follow, the various categorizations of the programming practices that we have to follow in order to be a good programmer, a good developer, and thirdly, we'll discuss the examples, the implementation of those programming practices using Java, because this is Java programming tips. And then I have a surprise for you guys at the end of the video, and we'll discuss how to emphasize, how to elaborate upon these lessons that we are learning here today. So let us begin with the first, why programming practices are important. So, guys, I'll give you a code snippet. Look at it for about 10 seconds and see if something is wrong with it. If you can figure it out. Okay. So as you can see in this code, we are using the 3.14 numeric value 3 times, and the code looks kind of dirty. It's not the most efficient way to write code. It's not the most readable way to write code. So this kind of implementation to write Java code is wrong, and we should never follow these methodologies to write code. So we'll look at another code snippet, which is the right way to write these sorts of code in Java from a production standpoint. So as you can see, this code looks way better than the previous code that I just showed you. This code uses functions to perform the Java aspects of reusability and abstraction. Here we can see the 3 result variables that we have all calculate their values using the calc function, and the code is reused. We don't have to write 3.143 times. This reduces the time in which we write code, and we can see there's proper indentation, there's proper spacing, and all of those aspects are implemented in this code. So this is the kind of right code that we need to use when we're developing Java programs. So this is the right implementation of the code. So similarly, these sorts of programs, these sorts of coding practices are important, and we'll discuss further upon it, and we'll discuss programming standards. So what are programming standards? See, basically, in any industry, organization, or business that you would work in, if they're operating successfully, they would have set standards of quality, and if you abide by those standards, only if you abide by those standards, you would get ahead in on any of those industries. Because any organization, in order to maintain quality, it has to have standards for the producers of the content that the company is dealing with, and for the consumers as well. If there is a set standard, and you can always be assured that there is quality in the kind of code in the software environment that we are developing programs inside. So it results in better quality product, and in the most cost efficient and most time efficient manner possible, basically. So that is why we need to have programming standards in the software industry. So we'll discuss on the points on why these practices are good and why we need to use such practices point by point. Firstly, time efficiency. So guys, as I discussed before, we used code reusability. That emphasizes that gives us an advantage when we are trying to write code on a time constraint. So basically, we don't have to write the same sort of logic, same sort of code again and again in a 1,000-line code program in Java. We don't necessarily have the privilege to use these sorts of repetitive measures. So we basically can write one snippet of code in a function. We can call that function again and again. That is what time efficiency is. We'll further discuss on how time efficiency is implemented in Java as we discuss the implementation examples. Code readability. Obviously, proper spacing, proper indentations, proper divisions, modularity in code is very essential for code readability. We'll also discuss that in the implementation examples. It's also important because you're not going to be the only person that is going to be working on a certain program in an industry environment. There are going to be programmers that are your peers and going to be working on the project simultaneously as you. There are going to be new people who are coming in the project, so they need to know what the code does. So you can't be like you write a code and you only understand the meaning of it, and the other person who comes in and he doesn't understand what the code is about. So you need to be clear in that aspect. The code readability should be good by you and by others who read it. It's a very important standard in when we're discussing good coding practices. The next point is security. Obviously, there are going to be certain variables, certain functions that the other developer team is not supposed to have. They shouldn't have access to it. They shouldn't have access to certain variables. So in Java, especially, there are a lot of features to implement secure measures in programming, so that nobody is able to break a certain element of the code or a certain element of the program, and it all goes smoothly. The next point is minimal complexity. Obviously, if you do programming, you understand the time complexity is very important. Memory complexity is very important when we're discussing code. And we'll also discuss that with certain examples as we go ahead. To minimize upon processing power and time, and to basically be within the time constraints that the program is supposed to run in. The next measure that we have is memory efficiency. Obviously, we shouldn't take up too much of the hardware resources, the physical memory that we have. The program should utilize as less of memory as it's supposed to. And next point, it should be easy to maintain after your build is complete. You obviously would need to make certain changes to it as the world evolves, as the consumer evolves, as the features develop, as dependencies change. So it is important when you go back to the code, you understand what the code is. This is also an additional point over code readability, that your code should be easy to maintain. You should know when you go back to the code. Any other person should know when they go back to the code how the code works and what every function or every variable does. Reduced risk of failure. Obviously, if you've been programming, you know that even if one thing goes wrong in an entire program, it could break the entire build. So that costs a lot of time, a lot of effort, a lot of money to fix. So it's obviously better to implement good coding practices to reduce the risk of failure and reduce all of those costs. And lastly, comprehensive view, which means it's also an additional point over code readability, which basically means that when you look at the program, you also understand the bigger picture that the program is operating simultaneously. You don't have to go look at every module, every code snippet that there is to understand what a program does. You just look at the code and you understand what all of it does just by looking at it. So moving on. Every organization basically in the world follows these coding practices, and without these coding practices, it is very difficult for any organization to have a production environment, have a running smoothly production environment. So to get hired in any of these following companies and more companies as well, you need to be very well aware of these coding practices. So now we move on to types of programming practices, discussing it one by one. Firstly, we have readability-oriented programming practices. Obviously, we discussed readability before with the code snippet example that we had, and further. So basically, we'll discuss that with examples, how you can write code that is readable by you and readable by others, whoever joins the project or are working on the project with you simultaneously. Secondly, we have modularity oriented code. This is modularity basically means dividing programs and functions and variables with similar functionality into modules. So basically you would use modules which have closely related functions and variables, and you would use it in your code. So it's important that every module is divided according to its functionality, and whenever you import a module, whenever you use a module, it has functions and variables related to that functionality only, so that you understand the specific functionality, specific purpose of the module that you're using in your program. Next, we have efficiency oriented. Obviously, we discussed time complexity before, we discussed memory complexity before. Those all are points that contribute towards efficiency. How efficient is your program? How efficient is it with time, with memory, with hardware resources, with personal resources, and all of that. So next we have no redundancies. Basically, this implies that your code should not have parts to it that serve no function to the program, serve no purpose to the program, but they're still there. It basically adds to the confusion and is not generally a good coding practice to have parts of program which serve no purpose. So we will discuss these programming practices, these categories one by one with examples as we move ahead. Now, next we have implementing these programming practices using Java. So we'll discuss these examples that we just had using examples. First, we have readability oriented, as we discussed before. The first measure that we would use for readability oriented programming practices are practice number one, use blocks wherever necessary. Obviously, there are a lot of times I've heard people say that certain parts of the program, like an if statement, you add your code to the next line and the blocks are not necessary. Yes, it's a general practice. It's a more efficient way, more speedy way to write code, not a more efficient way, obviously, because it doesn't tax the processor or anything. It's a more speedy way to write code. But when you have thousands and thousands of lines of code, it could get a little bit confusing where the module of a if statement, where the block of an if statement begins and where it ends. So it's always essential, always useful that you add curly braces and create a block wherever you can, so that when you go back and look at the code, you understand how the code is functioning and you have no confusions. Basically, it's good for from a debugging perspective as well. Next, we have practice number two, use comments. Obviously, rather than just writing functions functions and variables obliviously without any context, is a bad practice, coding practice in general. Comments, you should always use comments to describe what a function is exactly doing. You should add parameters in the comments of what the exact parameters are, and this overall adds to the readability of the code, as we were discussing before. Next, we have use meaningful naming. A lot of times, while you're learning Java in your schools and colleges and in courses, the instructors and the way you're taught Java is to use whatever variable name that comes to your mind, because you can put variable names as you desire. So that's not generally a good programming practice from an industry standpoint, because again, when you're writing tens and tens of thousands of lines of code, when you're using variable names like int a, string b, that is not generally good practice, because when you're about to debug the program, or you're going about maintaining the program, you might not know where the A is coming from, where the B is coming from. So it's definitely a good practice to write the variable name with a little more context, so you understand by looking at it what it actually implies, what the functionality of the variable is. So using meaningful naming obviously enhances the program quality, the readability quality of your code overall. Practice number 4. So using proper indentation. So basically, what indentation means is tabbing your program, spacing your program with a line alignment according to a statement, so you know where your block begins and where your block ends. That is what indentation means, and it makes your code look cleaner. It makes your code more easy to debug or to understand by any other person, and even by yourself. So it's also a good coding practice to use proper indentation. Practice number 5, use proper spacing. So as you can see in the first example that we have, that is the wrong example. We have int result equals to first plus second divided by 2 mod 45. And it looks okay, it looks workable, you can understand it now, but when you're trying to debug a 1,000-line program in Java, it's kind of hard to understand. You might do a calculation error, you might do a syntax error if you are not proper with your space and you might not understand what you've written. So it's always a good practice to use proper spacing between variables whenever you're writing expressions and such. Using blank lines to represent proper code separation. You can see the first example that we have is quite it's not the most efficient way to write code. It's creating a lot of confusion as to where a function ends and where the function ends. So it's always a good practice to use proper spacing between different lines of code to properly understand where a function begins and where it ends, to essentially separate the code into separate modules so you understand it more clearly while you're looking at it again. So moving on to the next practice that we have, practice number 7, declare variables near to their first usage. A lot of times I see people declaring variable names in the beginning of the program and not using it until the very last. So that's not a very good practice, because it works well when you have a 40 line of code program, 50 line of code program, but when you have a long program, so you might not know where that variable was declared, if there is an issue with it, and if you want to change the data type that the variable is off. So it's generally a good practice to use the first declaration of the variable near to its usage. So instead, in the first example, as you can see, we are writing int first equals 0, and then there are 1,000 lines of code, and then we're using first. So better practice is writing the code first, then using int first equals 0, and then first equals to first plus 1, which means that where the code is where the variable is used first, we're using the declaration there. So moving on to the next practice that we have is modularity oriented practices. So modularity basically means that, as we have discussed before, functions, variables, resources with similar usage packed into one module, and we use those modules in the implementation of our program. So we will now see the practices related to modularity oriented practices basically. Practice number 1, use of packages and resources. So I'm sure you guys have developed programs in Java before, made programs in Java before. You've done the import java.io.asterisk. So basically that is a package with the functionality of input output services all packed into one. So you're using a module basically to do all the input output functionalities with the import java.io.asterisk import. So similarly, you can write separate classes, in separate class files, and bundle them into a package and use them in your programs, which is a much more efficient way than writing every class, every function in one program only. So you can separate different functionalities, and it's in general a much more easy to read, easy to understand practice in Java when you use modularity. You can also use for XML files and such. You can also use build tools like Gradle and Maven. Moving on to the next, we have efficiency-oriented programming practices. Obviously, efficiency-oriented means that you are using programming practices that are easy on your hardware resources and your time resources and your monetary resources, basically. So we will now see what these efficiency-oriented programming practices are. Efficiency-oriented practice number 1, which is it's a general practice that I've seen whenever people import the traditional java.util.asterisk or java.io.asterisk. It's not necessary to import all the classes that the java.util package provides. You can only use the one that you actually need in the program. It's easier on the memory to do that. So be sure to understand that whenever you're using only array lists from the java.util package, it's not a good practice generally to use the asterisk because it goes easier on the memory that your program is using. Number 2, obviously, if you're replicating code logic, then it's harder on your processor because you're using a little bit of extra resources from your processor, which you don't actually need to, because the logic that you're using is redundant. As you can see in this example that we have here, there's a if 1 less than 2. So obviously, when you're writing that, which means the opposite, the else statement of it would have been one, if else would have implied one greater than equal to two. But here we are using an else if statement, which is basically implying that the Java executing the JVM has to basically also check if one is greater than equal to two, which is not a necessary aspect to this code that we have here. So we don't need to do that. We could have just as well added an else, and the JVM wouldn't have had to calculate one greater than equal to two. That's what it means. Going a little bit easy on the processor where we can, basically enhancing the efficiency, enhancing the speed in which the program runs. On to the next. Yeah. So also an aspect when we're emphasizing, when we're improving the time complexity of a program, which is very essential. We avoid using nested loops as much as possible. So to write code in a much more efficient manner, which runs in a much more efficient way, in a much more time efficient way, wherever we can, we should not use nested loops. And even if we are using nested loops, we should be sure to have those loops running in a constant time complexity instead of an on time complexity, is basically what avoiding nested loops as much as possible means. So there are certain other practices in efficiency oriented practices as well, which we will discuss now. The other practices are use dynamic over static wherever you can. So this basically means, static basically means that whenever your Java compiler wherever your Java compiler compiles the program, it allocates memory to every static variable and static function that there is in the program. So memory is allocated before runtime, and it's not the most efficient way to write code. Say I make a Java array of 100 elements, and we might not need all those 100 elements, but because we're using a static methodology to it, we are creating those 100 elements anyway. So that's not a good practice. Instead of that, we should use a dynamic way to do it, where we only create the elements that we need throughout the execution of the program. It's a better methodology to run programs, and it runs in a much more memory efficient way. The next practice that we have is hash maps and lists over conventional Java arrays, always, because conventional Java arrays, as I discussed before, are an example of static memory allocation in Java programs. You don't need to declare arrays with 100 elements, with 1,000 elements altogether when you don't need it. So hash maps and lists are an implementation of dynamic programming. So basically what that means is lists you can append as you go. Whenever you need a new element to be added, you can append it to an array list that you have. So instead of declaring 100 elements altogether at once, of which you might not need all the elements of, you can just declare an array list, and you can you can add elements to it dynamically on the execution of the program as you need them. Hash maps also contribute towards dynamic programming. Hash maps are basically lookup tables for certain key values, key value pairs. So rather than using Java arrays to iterate upon every element that is present in the Java array, you can just use a hash map and look up the value corresponding to a key. So all of these help in time complexity management and memory complexity management. Thirdly, we have usage of string builder over concatenation. So basically, strings in Java are objects. They are not conventional primary values, primary data types. So what a string is an immutable object. So basically, when you declare a string, it creates an object. But when you change a string using just a string, then what happens is you are basically creating another string. So in the temporary garbage heap that you have in Java, it creates a lot of garbage values that you don't actually need. So a much more memory efficient way to handle strings is using the string builder or the string buffer. So whenever you're concatenating on a string, it's always better to use a string builder. And the functionalities associated with the string builder rather than using conventional string concatenation, because whenever you run an uppercase operation on it or a lowercase operation on a string, it creates another string with an uppercase. So as long as the garbage collection routine has not occurred, there is unnecessary garbage values in the temporary garbage heap that you have in Java. So it's better to use string builder or string buffer rather than conventional strings. So these basically in Java, these practices help you enhance the efficiency of the program that you have. Moving on to the next, we have no redundancies. This basically means that whatever part of your code, whatever part of your program that you have that is non-essential to the program, you basically eliminate. And we'll discuss this with examples as we move on. So the first practice that we have regarding this is reducing redundant lines of code. As you can see in the first example, from a logic standpoint, we have public boolean check truth. So we can see that a equals to 1, and we're basically using conditional statements. If a is 1, then we return 2, else we return false. So there's a better way to do this and a way to reduce the lines of code that we're using here. So basically, if we just use the return a equals to 1, we basically do the exact same thing as the first code is doing. So knowing these methodologies to reduce redundant lines of code is very important, as it reduces the lines of code and makes the program easier to understand. So this is one example of redundancy. The other example is say we are obviously every function can have parameter values. So say there are a lot of parameters. Here we only have a and b, I know, but say we have 17 parameters that we have to pass over to a function. So it's a generally inefficient practice to write all 17 parameters in the function definition, where we can only just import the object. As you can see in the correct example that we can just have the object passed as a parameter, and then we can use the variables associated to the object, and we don't have to worry about passing the values in the right syntax from the place where we are calling the function from, and coordinating with all of the data types and everything. We can just pass the object that we have, and we can use the values as we desire. So this is a better implementation of passing values than using variable parameters for every variable that we're passing. Next, we have practice number 3, which is basically removing redundant lines of code from the program. A lot of times when people have a function name called check truth, which is basically just supposed to return a true or false, when we're using it in the main program that we have in the base, in where we're using check truth function, we shouldn't have other functionalities that the check truth function is doing as well. Like here we have system.out.println hello world, which is not the function that check truth is supposed to have by name. So it's basically whenever another programmer is using it, you know the context of when you use check truth, it will print hello world. But if another programmer is using the function check truth, he might not know that the check truth function also prints hello world. So it might be a problem for him. So it's always better, it's general better coding practice to always have the function do what it's intended to do. Next, we have avoid lengthy functions. Obviously, you need to modulate your program as much as possible. Basically, reduce every function that you have into further modules if it's a long function, because having lengthy functions means that if a person is supposed to debug it, if a person is supposed to look up what the function does, and it has a lot of lines in it, then it might get confusing. So it's always better for every functionality that even one function does, we should divide it into separate functions to modulate it better, to understand what each functionality of a certain method is doing. So moving on to the next, that's to avoid zombie code. So what this means is, if your program has commented out functions, commented out statements in it, as you move towards the final build of the program, you should remove it, because if another programmer is acting on it, if you are acting on it, and you mistakenly remove the comment, it might break the entire build of your program. So when a program snippet, when a code snippet basically becomes redundant as you move towards the final build, it's always better to remove commented outlines of code. So that is about it in the practices that we have. Now moving on to the further learning that we have. So basically, if you this is just a tutorial, right? This is just you understanding the basic fundamental programming practices that we follow in Java. But that is not going to be enough for you if you're wanting to become a Java developer in a professional, industry-oriented environment. So what do you need for that? Obviously, you can look up Google, you can search up study material and everything, but a proper way to understand all of these aspects of Java, all of these fundamental logics that Java has, is going through a course which is specifically targeted to make you understand what and how Java functions and how Java is implemented in an industry oriented environment by industry specialists. So for that, you can obviously check out the Java courses that we provide at Intellipaat. So I'm just going to show you what courses we provide. So here we have our Java courses that we have. We have 2 Java courses that industry specialists and industry trainers are giving to you. So firstly, that you would be interested in if you're beginning with Java is Java training. Here, as you can see, we have our key features. The course duration is 16 hours, so it will not take much of your time. It's a self-paced course, so basically that means that you can you can do this course at your own pace. You can do all of these the assignments and the course lectures, all of that at your own pace whenever you want. And then we have hands-on, which means that we have projects and lab in it. So basically, industry-oriented projects we provide. You can check them out, and once you are successfully able to attempt them, you'll have confidence, you'll have something to show for your Java training certification that you have. The access for the course that you have is for a lifetime. So basically, what that means is the course never expires. Once you've bought the course, you can access it anytime. And we also provide a feature that is whenever there is an update in the software, whenever there is something new that comes in the software, we update the course accordingly, and the newer course is available to you for free. So you don't have to pay anything extra for any updates that comes into Java. The course will be updated automatically and you will have the access for free. We also give Get Big Data Fundamentals self-paced course for free if you enroll right now. So that is also a feature that we provide. You can get that course for free. We give 24/7 support. You can contact support, and we provide 24/7 assistance with any issues, any doubts that you have, any technical doubts with any projects, any other doubts that you have in the course. We have a flexible schedule. Obviously, it's self-paced. You can attend to the course any way you want. And once you've completed the course, we also are very glad to provide you with job assistance in the Java field. So about the Java training course, the curriculum that we have programming and core Java concepts, inheritance. We have JDBC, which means connecting to a database. All of the basic fundamental aspects of programming that you have. We discussed array and hash maps right now, and dynamic data. That also you have in the course. We have all of these concepts in Java that you could look up if you go to intellipaat.com. And we just don't provide Java, we provide a lot of courses, and all of those courses come with the same exact features. So moving on to the next, we also have reviews by industry specialists today that have taken up the course and are doing well in their particular domains. Successful Java trainers. We also have text reviews. Now, moving on to the slides. Further learning. An investment in knowledge always pays best interest. You can check out our Intellipaat website. We have a booming community asking all kinds of queries and all kinds of solutions. We have our blogs based on various subjects that we provide. Our YouTube is updated regularly. You can check out our YouTube channel, Intellipaat, as you have subscribed, and so there we provide a lot of courses on our YouTube channel. You can check it out. So the surprise I was talking about, if especially for our YouTube audiences, if you use the code YouTube30 while you're subscribing to the course, while you're taking up the course, you get it for 30% discount. This is only for our YouTube audiences, so you can get it quick and move on with your learning. So that's about it for the session. If you have any doubts, if you're in India, you can call us at the Indian number that we have. If you're in the US, you can call us from there. If you don't want to call us, if you're shy, you can contact us at sales@intellipaat.com, and you can also have engage in our 24/7 chat with our course advisors if you contact us. So that is about it for the course. See you guys again in the next session.